Good afternoon, everyone. Thanks so much for joining us today. We have some good information on all teed up for you today on Wi-Fi, and particularly around how some of the more difficult places to put Wi-Fi and to have it perform well. And those are some kind of large facilities, and we'll kind of talk about some of those in a lot of depth today. So hopefully that gives you some good ammunition as you need to kind of go back and fight the good fight for making sure your Wi-Fi is top-notch in your facilities. I'm joined today by Alex Wilson. Alex is a wireless engineer with extensive experience from just kind of the vanilla office spaces all the way up through arenas, large worship facilities that hold several thousands of people, outdoor events with thousands of participants, and all the Wi-Fi that would span very large open kind of outdoor events, as well as long haul and tower work. So lots of experience to tap into with Alex. So let's take a look at the agenda. So we'll kind of look at some of those unique challenges. What are the challenges? So we know we're kind of solving those kind of large industrial types of things. High rise, you may not think of high rise as being a difficult space, but it can be because of density. So all the people and everybody's got wireless access points that are competing with their neighbors' wireless access points, and obviously outdoor environments. We'll talk about some of the design and management things you need to be thinking about to make sure that the Wi-Fi is going to perform to your specifications. One of the unique things about arenas, large worship facilities, those types of things, is that most of the time nobody's there. They've got 5 people accessing it until an hour or 2 or 3 a week, and then you have thousands of people using it. So obviously it affects design. We'll look at some of the best practices to follow. We'll get an update on Wi-Fi 7, and a very interesting case study, or actually several case studies, will be used today. And then finally, Q&A will be at the end. Hopefully you have a pizza in front of you by now. If not, just be patient. They may be looking for your address if you're working from home or your office. Check wherever food seems to disappear to in your office if you haven't seen your pizza, or a lot of times the front door of office spaces are locked, so you may find that delivery driver on the other side of that locked door, just waiting to give you your pizza. If not, reach out to Julie. Her email address is right there on the screen. A little bit of additional housekeeping here. So first is audios and presentation mode, so you can hear Alex and I, but we keep it on mute for participants, so that any sound where our participants don't come through to the whole group. Keeps any distractions away and allows you to be able to concentrate on the content. However, you can reach me at any point through the chat tab right there and go to webinar. And any questions that come to mind, just drop them right into the questions tab. I will save those up to the end. I'll read out those questions that have been submitted at the end of Alex's presentation, so that Alex can reply to your questions. So just drop those in at any time. This presentation is being recorded, as well as the deck will be made available to you this afternoon, so that you don't have to write furiously. And then finally, there is an evaluation at the end, and it takes literally less than a minute. Let us know how we did, one, and number two, it gives you some suggested things that you might find to be useful resources after the fact, and you can go ahead and note those, or just note whatever it is that you might need, and we'd be happy to try to help you out with those things. And we try to make it a little bit fun by taking going through the completed evaluations and picking one of those for a $50 Amazon gift card. So hopefully that's you. So most of the folks that are on this session today are very familiar with System Source, so I'll just be brief here. So obviously folks have been working with us since our founding in 1981, and people come to us when they need to acquire new technologies. So one of the areas is going to be in wireless and security, all the switches that go with it, as well as basically all the things that make that modern data center go, whether that's an on-prem data center, it's in Azure, it's in AWS, or it could be in kind of software as a service. It could be hosted servers at all different kinds of other facilities. So wherever your data and your storage and your security requirements and your virtualization, wherever those things live, those are the kinds of areas that we do our work. We're agnostic to where kind of where the resources are, We want to make sure that it's designed in ways that make sense for our clients. And so our senior consultants over where it says improve help to do that work, as well as in the cloud. Training is our training group, which has about 600 plus courses at any one point on its website. And that's going to be in all the types of technologies that I've just mentioned, as well as digging into specific manufacturers. For example, Cisco training might be one of those, or VMware, et cetera, as well as the whole Microsoft stack. Present is professional AV, so think of all the Zoom rooms, AV room, all the Zoom, WebEx, Teams rooms, so all the monitors and projectors and cameras and speaker systems and microphone systems that make those kinds of spaces work, whether it's from a huddle space all the way up through large arenas. That's the type of work that our professional AV group does. Finally, we maintain all the things I just mentioned there. Either you call us when you need help under service and support, reactive, including after hours, you just dial it through the main number and follow the voice prompts, or managed services where we are the IT department for dozens of clients. So that's a little bit about System Source today. We do have some upcoming events that you might be interested in, quite a number of them. One tomorrow is going to be on server management, so interesting things for that. Then next week we have one that's going to be on why consider moving to Microsoft Azure. So if you're kind of earlier in the stages of thinking, where do I want to go from a cloud standpoint, that may be an interesting session for you. Coming up on the 21st, that's going to be an interesting, we get a lot of questions about, well, what's the difference between a managed security service and a SIM, if I just want to buy a SIM for those types of things. So that will kind of break down this, and there's not a right or wrong answer there. Some folks want to run it internally, others want to have others run it for you. What's the kind of the middle ground there? We'll dig into that during that session on the 21st. And then on the 2nd of next month is going to be really digging deep into HPE storage. So for those that maybe want to do one more refresh on-prem, those are the upcoming sessions. With that, let me turn the reins to this crazy horse over to Alex, please.
Alrighty, well, good afternoon, everyone. I'm going to talk to you today a little about Wi-Fi design in large open spaces. We're going to take a look at the state of wireless, talk a little bit about Wi-Fi 7, what features are there that are going to help you with these open space situations. And we're also going to define open space, because a lot of people start to think of open space as just arenas or open event fields, things like that. And there's a lot of other areas that this applies to. We'll talk about the different types of access points that we might use, proper design techniques, getting to know your audience, which is a major part of building the correct design, because you can really over design these, or you could way under design them depending. And then we are going to take a look at some case reviews of some real projects that we've done over the last couple of years in a variety of different types of spaces. So we're going to look at things like, we're going to look at a large church sanctuary. We're going to look at auditoriums, gymnasiums, large arenas, event fields, and so forth. So how do we define a large open space? Basically, the way we look at it is, it's really any situation with minimal walls or obstructions, and it's going to require more than one access point. So this could be a large library that's just an open library, for example, and it's going to need several APs. It could be a warehouse that's open. It could be a large auditorium or event field. So many different things. We also think of offices, even with open office plans or cubicle farms. Church sanctuaries are definitely, a big open space. And so the common things that these have are potentially high user counts, and then also tall ceilings or wide open spaces that need a variety of coverage. So let's take a look real quick at the state of wireless so we understand what features. We go through these states of wireless pretty much in every webinar we do, but I want to focus today a little bit more on some of the features. So I'm not going to spend a whole lot of time on the background. Real quick though, a reality versus marketing. There are two organizations out there, IEEE and the Wi-Fi Alliance. IEEE is who sets the standards. These are done by committee and they take years to adopt. And I'm not kidding when I say years. The Wi-Fi 7 standards should have been adopted I believe 4 years ago, actually. Um, and they keep moving it, and it still technically has not been adopted, even though everybody is selling it. The Wi-Fi Alliance builds a list of standards that they test against. And so in order to get branded with a Wi-Fi certified logo, your product has to meet certain standards. And it's not always every feature of Wi-Fi 7. So as an example, in Wi-Fi 7, 6 gigahertz support is not required. You only have to have 2.4 and 5 gig. So if your device is 2.4 and 5 only, but meets all the standards for Wi-Fi 7, then you can get approved. And so a lot of people have a misunderstanding when they go buy a Wi-Fi 7 access point that it's going to have 6 gigahertz support in it. That's not necessarily the case. And so it's important to understand the difference between the two. So IEEE creates the idea of the standard, and then the Wi-Fi Alliance is the marketing brand that goes behind it. And they're not connected whatsoever. So real quick, what happened to Wi-Fi 6? Weren't we just talking about this yesterday? It just seems like it just came about. In reality, Wi-Fi 6 was another one. It was actually supposed to be adopted somewhere around 2019, but didn't get adopted until 2021. Nothing has happened to it. It's still there, and it's actually the most current and readily available standard that's actually approved. Because like I said, Wi-Fi 7 still technically has not been adopted fully. There was a general slow adaptation rate in moving to it simply because of all the supply chain challenge, the post-COVID cutbacks, confusion over where everything was going. I mean, people were already starting to talk about Wi-Fi 8 before 7 even started hitting the ground. Vendors are still releasing products in this space. Not as many, but a lot of them are releasing products in the Wi-Fi 6 space still. And then recently, the FCC finally got around to approving the vendors for the 6 gigahertz automatic frequency coordination database hosting. And this is an absolute requirement in order to use 6 gigahertz in an outdoor setting, which is very important for large open spaces. So what is the AFC? Oops, I got a typo there. I'll have to correct that later. The automatic frequency coordination database is kind of like, it's similar to the DFS concept. So DFS was dynamic frequency selection. It applies to certain frequencies in the 5 gig spectrum. What happens is if you're using a DFS channel, your device has to check to make sure nobody else wants those frequencies. And when I say nobody else, I'm talking about other types of uses, not for Wi-Fi, but for certain marine radar, weather radar, spaceborne radar, and amateur radio communication. So if another one of those services requests that particular channel, they get priority over your Wi-Fi, and your Wi-Fi has to move to a different channel. That bothered a lot of people because it made it hard to do channel planning, but you're going to find in these large open spaces, you absolutely need to use DFS channels, because if you're not using DFS channels, you're not going to have enough channels to create uniqueness. So what this database does for 6 gigahertz radios are used in a licensed manner as well. So a lot of your telecom carriers use 6 gigahertz for backhaul between cell towers. It's a great medium for high data throughput at long distances. So with their microwave radios on 6 gig, they're doing shots of 1 mile to 30 or 40 miles in some cases between towers. And they're moving as much as a gigabit of traffic at a time. So they're moving a lot of data there, and they get a license for that. And so if you start firing up access points on the same frequencies as what they're paying for a license, they're not going to be happy when you interfere with their radio. So the automatic frequency coordination database is a requirement. Your access points have a GP, if they're outdoor enabled 6 gig APs, have a GPS and a gyroscope in them. And the idea behind the two is the GPS detects where on the planet they are and at what elevation. And so they can use that information to quickly scan the license database to see if there's somebody in that vicinity that could be interfered with by your access point. And then the gyroscope is used to determine the actual position, which way it's facing, so that they can actually, oh, gee, you're facing straight down, so we're not that worried about it, versus you're pointed straight out and right towards our licensed dish. And so what that will do is it will block access to that frequency and make you use a different one. But there's plenty of spectrum in 6 gigs, so we're not too worried about that. And it happens very fast, very quick. We did some tests on it at an outdoor space recently, and we had no loss of data traffic while it was switching. And so basically what we did was we fired up a 6 gigahertz source that caused it to trigger, and as soon as it hit it, it switched pretty much instantly, and we had no data loss, which was great. So when will we start seeing Wi-Fi 7 devices? Well, like I said, it hasn't been finalized. It was actually supposed to be finalized back in January. This is pretty much typical, and of course, we also have the whole political situation going on right now with the change of administration, which does affect, because a lot of these committees are made up with appointees and such. So it'll take a little bit of time, but it doesn't really matter. The vendors are going ahead and moving forward. They don't expect any real changes at this point. And so Cisco, Meraki, and Aruba, for example, all have devices that support Wi-Fi 7 that are shipping today. Now, I'm not going to say that they're all 100% perfect, and I'm not referring to these 3 vendors, but all the vendors are having some challenges with some of the chipsets, and everybody's having different challenges with different chipsets. So there is some stability that needs to happen before I feel really comfortable with the Wi-Fi 7 devices. But so far, what I've seen with Cisco's, Meraki, and Aruba, they seem to be hitting it pretty good, and we're not really seeing too many issues yet. So why should you care about Wi-Fi 7 at this point? Well, number one, you need to understand it, see where it fits into your strategic plans. And much of what's in it is actually available in Wi-Fi 6E, which provides the 6 gigahertz support. So a lot of the capabilities are there in Wi-Fi 6, but 7 takes it to another level in a couple of spots. Specifically, 2 features I want to talk about today: MLO, or multi-link operation, which allows you to transmit and receive over multiple bands at the same time, and then preamble puncturing, which allows you to block out parts of a channel that are noisy. These 2 are absolutely game changers in the large open space environment. So let's take a look at MLO. So the concept of MLO is that if you have an AP with, say, 2.4 and 5 gig, maybe it also has 6 gig support, you can transmit and receive on all 3 bands at the same time. Today, you can only pick 1 band at a time. And so if you're on 5 gigahertz, but you're not getting through that wall, 2.4 might get through the wall better, but your device isn't going to switch over just because 2.4 is a better choice. It doesn't know that. And so with MLO, it gives it the ability to bond, essentially, all 3 bands together to allow you to span back and forth. So it can leverage the best option for every given situation, and it will absolutely help increase throughput. So for example, 2.4 is not known for its throughput, but it's known for its distance and penetration. 5, not known for its penetration, but known for its throughput. And then 6, well, we've got great throughput, not so great on the distance. So it can leverage all of them based on a given situation. Preamble puncturing is an interesting one, and what it allows us to do is to carve out a slice of the channel to avoid interference. So I'm actually broadcasting right now from a hotel where I'm staying at the moment, and in this hotel, everything's on an 80 megahertz channel. The problem with that is there's only 6 80 megahertz channels available, because what they do is every channel in 5 gig is 20 megahertz wide. So when you hear me refer to channel 36, that's a 20 meg wide channel. Channel 40 is 20 meg as well. Bond them together and you have a 40 meg channel. And that's how this works. So in order to get to an 80, we bond 4 channels. So 36, 40, 44, and 48 would be bonded. And that works great, except the neighboring hotel has everything on 40 meg channels. And so over there, they're broadcasting on 36 and 40 at the moment. And the AP that I'm sitting near is broadcasting on 36, 40, 44, and 48. Well, we have an overlap. 36 and 40 are both being used by 2 different APs. With preamble puncturing, well, without preamble puncturing, I have to sit here and wait. So while that other AP is busy, even though it's not on the network that I'm sitting on, I have to wait until they finish transmitting before I can transmit. And so that creates delays, that creates throughput issues, latency, dropped packets, all sorts of problems. And so since the neighbor over here is on 36 and 40, if I were to have an AP that could do preamble puncturing, my access point will just say, you know what? 40 is better than 80, so I'm going to drop 36 and 40 for the moment and just use 44 and 48, eliminating the noise and eliminating the delay. And so the phrase sometimes less is more really truly applies here, because now all of a sudden I'm getting there, maybe not as fast as I could be, but I'm getting there, and that's what matters, rather than sitting here and waiting in traffic. I kind of look at it as taking a detour. When the highway's crammed up, a lot of times we jump off the highway and we take a back road to get there. It may be slower, it may be a little longer, but we're going to get there. We're not going to be sitting in traffic waiting. So preamble puncturing is absolutely a game changer in these environments, because one of the things you're going to have in, say, a large arena or an auditorium or a church sanctuary is every participant bringing in a hotspot on their cell phone. And that will absolutely wreak havoc on your wireless network. And so it has the ability to get around that when these are narrow channels that are being interfered with. So some things to keep in mind, though, with Wi-Fi 7, if you're thinking about making the move, the power that you need to run a Wi-Fi 7 device goes up. The vast majority of the Wi-Fi 7 access points are going to require 8023 AT or higher. So 803 AT, which is PoE plus, or BT, which is PoE plus plus. The base wattage use is much higher on these APs. So you're liable to need new switches with higher PoE levels. And that translates into some other things as well, which I'm going to jump ahead real quick. And that's your HVAC and your UPS needs. So if you're increasing the wattage on your switches in the closet, you're going to increase the heat level. You're going to increase the amount of power required to run these. So you're looking at some potentially, need to look at your HVAC as well as your UPSs when you do this. The other thing is going to be your network needs. Most of these newer APs have at least a 2.5 gig, if not a 5 or a 10 gig network port on them. Now, that doesn't mean you have to rewire everything to 2.5, 5, or 10 gig. You can run with 1 gig, but just remember, you're never going to fully maximize the capability of that access point. Also, some have dual ports to do lag so that you can bond the 2 ports together. So a lot of them have 2 5 gig, and then you can bond those together to create a 10 gig solution. So now you might need to run a second line to that AP, or in the case of some of the bigger APs, like your stadium access points, they use a 10 and a 1 on each of them. So the 10's for data and the 1's for PoE. So some things to consider when you're thinking about these projects. You've got to look at the entire environment holistically. So should you wait for ratification? I would say not at this point. And the reason being, everybody's pushing these out the door. They're not really going to make any major changes. if anything, this is a death by committee process. They might change the way they word something, and that's really to the extent of it. But you may also be wondering, should I wait for Wi-Fi 8? Isn't that coming right now, or isn't that around the corner? No, it's not even a draft yet. They're not expecting products to hit the streets until 2028, and even then, it's going to be mostly consumer-based products, not your commercial products. And right now, they're not expecting much to change other than throughput might get a little bit better. So in the long run, Wi-Fi 8 is starting to sound a bit like a snoozer to me. And I don't mean that in a bad way. I just mean it's just not going to be anything worth getting too wrapped up about at this point. And that happens in Wi-Fi. Every now and then we just have that little snoozer that comes along. So what are the types of access points that we're looking at here? So we have a lot of factors that guide our decisions with these types of environments. So first off, our ceiling heights. If we're going to be above 22 feet, we want to stay away from internal omni antennas. The internal omni antenna is typically not a very high gain antenna. The gain might be somewhere in the realm of 3 dBi up to about 5, maybe 6 dBi. And while that helps, it's not a lot. And so what ends up happening is once you get above about 22 feet, you start to suffer from free space path loss. And free space path loss is the amount of signal degradation we have over distance. And in the first 20 to 23 feet, give or take, is where we have our best signal. And then after that, it starts to drop off. And so what we want to make sure of is that we're not putting these APs 40 feet up in the ceiling and expecting them to perform brilliantly. They will provide fantastic wireless coverage to the birds that fly through the ceiling space, not so much to the people down below. We also have to keep in consideration the distance to our end users. So a directional high gain antenna can help overcome some of this distance. So if you think of a sports arena like a hockey rink, the scoreboard is probably one of the best places to mount your access points because they're right there and they can see every seat in the house just about. And so with that in mind, how high up are you? Well, I can tell you from experience, most of those scoreboards are somewhere in the 50 to 60 foot range. And then add the distance horizontally to get to the seating, you're looking at starting off at sometimes 70, 80 feet to the first user. And so you're going to need that high gain antenna to push that out further. We also have to consider the dimensions of the space, the layout, the terrain, if it's an outdoor event, and then also aesthetics matter. I'll be honest, a lot of these outdoor access points are ugly. They do not blend in well in an indoor space, but they're absolutely sometimes the best ones to use. So we'll talk a little bit about how you can make things look better. So let's talk about that standard Omni. So again, not suited for above 22. They have low gain antennas, and the signal pattern tends to be outward in a circle and down. So not so much out of the back of the AP if you were mounting it on the wall, or the top if you're mounting it on the ceiling, but more down and out. And as a result, you don't have isolation from each other. So if you picture a large open warehouse with access points every 50 feet, you can look from one end of the warehouse to the other probably and see every access point. So we've actually been in warehouses that are as long as 1,000 foot long and 400 or 500 feet deep. And the access point in the far corner can see the access point in the opposite corner. And when I mean see it, not just visually, but electronically. And what that does is that creates a tremendous amount of interference and noise. And so we want to isolate that where possible and create very controlled coverage areas. And that's not going to happen with an Omni. So they also make high gain Omni antennas, which are typically external antennas that can be added to certain types of access points. But again, they still suffer the same issue of not having any way to isolate them. Where would I use that? Probably outdoors in a large open event space, but not in a tight confined warehouse or sanctuary or auditorium or something like that. They're great when all you need is one AP or maybe two APs, and then there is something to isolate, like terrain or buildings or walls or things like that. Now, in order to use these, the access point has to have optional external antenna connections. So these are some examples of omnis that are used as externals. And so we have a high gain screw-on type, which literally just screws onto the terminals, and then you can bend it accordingly. There's also high gain. These high gain tend to be quite large, so don't let the picture deceive you. That particular one is actually about 2 feet tall, so it sticks out quite a bit. And then the one on the right is a high gain dome that actually is mounted either that way or the other direction. You can flip it upside down too. You do it this way if you're going to be outside. You can flip it the other way if you're inside. You get a little bit better coverage when it's flipped facing down on the indoor, but you're not going to get it as good when it's facing up. The problem is if you flip this thing upside down outside, the water is going to get in through the cable holes. And that's going to end up, of course, obviously destroying your access point over time. So the high gain directional access points have very focused beams, and the pattern size varies by model. So we can pick patterns that match our needs. Some are going to be cone shaped, which is pretty much an industry kind of default option. Some are fanned out wide in one dimension, narrow in the other. And those are great because I can use those to cover a wide open area, or I can flip it the other way and put it in an aisle of a warehouse, for example, and cover just the aisle or cover a narrow space underneath of me that's very long. The patterns can also vary by frequency that you're using. So for example, some of them, one vendor in particular that comes to mind, their antennas are cone-shaped pattern, which is fantastic, except the 5 gig is a 45-degree wide cone. The 2.4 is a 90-degree cone. And so we end up with this imbalance between the two bands. Now, another brand that I like to work with has much better imbalance, I guess you could say. And so their typical cone is 55, but it's 55 in both bands, which creates a very equally covering access point. Or maybe it's 55 and 45, which is fairly close. It's not going to create an imbalance in coverage. But again, you need external connections. Now, some APs, some brands are shipping internal directional antennas. Now, you can't adjust those. You have to aim the whole entire AP, which can become a mounting challenge because sometimes these things get quite large. So here's an example. These are both from a Celtex. The one on the left-hand side is an 8 dBi gain, so that's a high gain antenna. It creates a 114 by 24 degree pattern on 5 gig at about the same on 2.4. It's a little bit wider on 2.4. If I recall correctly, I think it's 120 by about 30. So fairly close, fairly balanced. Now, the really neat thing about this one is if I mount it the way you see it here, it's creating a widespread pattern in front of me. And it's a narrow beam top to bottom, but it's a wide area, so I can cover an open space quite well. Put this in an aisle face down, and you now cover the entire aisle. So with this exact antenna mounted at about 40 feet, we have covered 200 to 230 foot long aisles in warehouses with one access point and covered them absolutely stunningly. So it creates a very narrow beam, and we don't have issues with interference from aisle to aisle. The one on the right-hand side, another high gain option, this one's at 11 dBi, and this creates a 40 by 50 degree 5 gig pattern. So this is a cone, almost a cone. It's not quite a cone because it's a little squished on one side. So something like this could be used to cover a specific area. For example, the orchestra pit in an auditorium, or it could cover the lectern at the front of the auditorium, so that you're getting a very focused coverage in that particular area. So some of the access points with external antennas. Right now, 2.4 and 5 gig are fairly standard, and you can find a lot of APs with external antenna capabilities in those. 6 gig has to be limited somewhat because it requires a power restriction when outdoors, as well as it needs the AFC. So that's just starting to hit the street. So we're starting to see these tri-band options now. When you're buying your antennas, you have to be careful. You will need a triple band antenna for these. So if I were buying some antennas today for my 2.4 and 5 gig APs, but I want to switch them out later for APs that also support 6 gig, I probably want to consider buying triple band antennas today so that I'm not throwing the antennas away when I upgrade my APs. Also, you have to check because some of these antennas are indoor only, some are indoor outdoor. And the other cool thing is you can mount these away from the antennas. Go back here real quick, you'll see the wires coming off of the one on the left-hand side. Those are 3-foot leads that come with them by standard. And so all of those leads can just be fed through a hole in the wall, and this antenna can be left outside with the AP being inside. And that's a perfectly good option. Or it can be pushed through a ceiling tile or through something, that AP when mounted on a ceiling blends in. And all of these can be painted, which is wonderful. Just don't use any paint with metal flakes or lead in it, and you'll be fine. So these are some examples of external external antennas on APs. So the one on the left, the classic Cisco outdoor AP with all of the outdoor Omni antennas. From top to bottom, this is about 3.5 foot tall, give or take, about 3 feet actually. So it takes up a lot of space. The one in the middle, just a standard indoor AP with external antennas. And the position of the antennas is absolutely wrong in this picture. They should actually be, if this antenna were, if this AP were mounted on the ceiling face down, the antennas should be pointed straight down. So what does that do? In a short ceiling space, like say an office with a 7.5 or 8 foot ceiling, somebody could reach up and bump the antennas and misalign them. What I find quite often in office space is that these things are pointed at things, which does not actually work. Then the one on the right, you see the Aruba. We don't have the antennas on it, but you can see the ports. And those can either be the screw-on type, or that can be the wire leads screwing on there. And so, like I said, you can mount the AP in one space, and you can put the antenna somewhere else. So let's get into the good stuff here. Let's talk about the design. So first thing you have to do is understand your audience. So what's the highest user count you would expect? Of that number, how many are actually going to use your Wi-Fi? So we've done a lot of studies over the years with a lot of big vendors like Comcast and Spectrum and Cox and a few other cable companies who have gone into big arenas to light them up, and they do extensive studying. And what they have found is in these public venues, only about 10 to 15% actually use your Wi-Fi. Now, there are other factors that can change that, such as poor cell service in the area, data plan cost in general. That will drive uptake up a little bit. Also, we look at things like age and generational ranges, which will drive our use cases. So if it's a high social media user base, like a younger crowd, or a lot of photo and video uploading or streaming, that's going to drive up your demand and use on those APs. And then you also want to know, what are they there for? Are they here just to hear a presentation? Are they here to participate? Are they here to get entertained? Like, for example, at a sporting event. While we were doing an arena recently, we actually watched the crowds in the arena to see what they were doing. It's amazing how many people were watching the event on their phone while watching it live in person, because they wanted to get the instant playbacks and they wanted to catch the commentary from other people and such. Concerts, social media, big thing. People love to put up their selfies and live stream some of it. And so, if it's just a conference center and we're here to listen to a presentation, that's probably a lot of messaging. Now, these are the design considerations, and these are in no particular order. This was a random brain dump that I did. And these are some of the things that we look at when we're designing. So obviously, is this in or outside? What are the bandwidth needs? What are we looking at, from dimensions and layouts? What's the furnishing going to be like? What do we have to deal with from the neighbors and, anything around us and other services? What's the building built of? What is our construction? Are we talking about concrete, metal, wood? What are the different things we're dealing with here? When we're outdoors, we're worried about terrain. And along with terrain, I would add to that, and I didn't put it in here, but foliage, because foliage is the enemy of Wi-Fi in the outdoor space. Well, even on the indoor space sometimes. Other things, we're looking at the user counts. How do we mount these? What's the survivability? In other words, if we're going to be putting these APs up there, especially outdoors, are they going to live? If we're putting them in the gymnasium, are they going to get hit? Do we need to cover them? And what do we cover them with? Please don't cover them with a metal cage. It doesn't work well. So you have to look at some of those options. And then, other things, obviously, the growth, positioning of the crowd. Are they seated versus standing versus moving about? And what kind of client devices are being used here? Are we talking like a warehouse with hand scanner? Are we talking an arena with mostly mobile phones? Are we talking about a conference center with a lot of laptops potentially? So getting a good design, you're going to need someone that's got a solid wireless understanding. Basically, I say somebody with the CWNA, which is the Certified Wireless Network Administrator, or the Certified Wireless Security Provider. This level or equal in experience. So those two certifications are kind of a baseline that I would look for. They don't necessarily have to have the certification, but have that experience level. They should have a general networking understanding at least a CCNP, which is the Cisco Certified Network Professional level or equal. So basically a good network engineer, but they don't have to be that senior engineer. And they need to be familiar with the technical specs of everything being used. So not just the access points, but also the client devices. What do they need to do this? Well, they're going to need a wireless design tool that allows for complex designs, something that can set multiple ceiling heights, various wall types, solid list of the access points that they want to choose from. And then they're going to need to potentially test out these access points to see how they perform in the space. So they're going to need a spectrum analyzer to also check the spectrum in general for other sources of interference. And I do caution you on vendor tools. While they're great, they're cheap, they typically have very limited features. And yes, most of them are slanted to favor the vendor in general. So some of the types of design tools, we use Ekahau, which is our preferred choice, along with an Ekahau Sidekick. The Sidekick is a device that we carry on us that gathers all the data while we're doing our walk around. It has a spectrum analyzer built into it. It has multiple radios built into it to gather the data and process it. And the Ekahau package with the Sidekick, you're talking about $8,500 to get started. And that's just to buy the product. That's not even to figure out how to use it. The company itself, it's been around a while. It's a stable product, solid development efforts, and it's very flexible. Another option is Hamina. It's a fairly newcomer to the industry, but built by some of the same folks that built Ekahau years ago. Along with the Osseum Nomad combined, it's about $4,100, so a heck of a lot less. However, it doesn't have the spectrum analyzer capability built into it, so you're adding another $1,000 to $2,000 for a spectrum analyzer, so you're getting pretty close in price. It also doesn't have the reporting capability that Ekahau has and some of the other features. So it's a good product. It is a newcomer. They do have a solid development team, which is fantastic, and they're constantly bringing out new features. But one thing I will caution, in general, if this thing that you're looking to buy, whatever it is, costs less than about $2,000, it's probably not geared towards design. It's probably more for troubleshooting and telling you what you have, not what you want to have. And so the difference being a predictive tool such as Ekahau or Hamina lets you make a prediction about what is it going to look like when we're done. Some other things you need clean, accurate, scaled floor plans. You need a solid understanding of the construction so that you can duplicate it on the floor plans to get a good prediction. And then at a minimum, you're going to need to know what's the minimum signal strength. Do we need a secondary signal and what strength? What should our signal to noise ratio be? And what kind of latency or packet loss and interference can we tolerate before we start to have problems? A lot of this information can come from your client device vendors, but some of it also has to come from somebody with experience in this industry who understands what works and what doesn't. So there are a couple of design methods. The first one is the pure predictive. This is what I call the best guess, also known as a WAG, and you can figure out what that means. With this type of method, you're just basically relying on a model that you hope is accurate. And so it's only going to be as good as the data you put in it. And so if you don't know what these walls are made of, you're not going to make a good prediction. Now, if this is new construction or budget planning, it's a perfect tool for that because you don't have anything to go test. So you have to kind of wing it. And you can usually do these pretty quickly. The other method is called AP on a stick. This is the most accurate, but also the most expensive and time consuming because I need to have an AP on a stick, on a tripod or something that I put up at the ceiling. I power it up, and then I walk a test pattern to see how it performs. And then I move it and do it again, and I move it and do it again. So I need one of every AP and antenna combination that we're going to use on this design. The challenge there is I probably don't know what we're going to use yet. And so the thing is, I usually have to do a predictive before I can even do the AP on a stick, just to get an idea of what we need to have in here for testing. It often requires more than one person, so now your cost is going up. And then the equipment you need power supplies or battery packs to power these things as you move around, and it can get quite expensive. My average kit for an AP on a stick runs about $15,000 to $20,000 in cost for all of the products you need just to do a simple warehouse or a church sanctuary or something like that. And then the other method is a hybrid, and this is the method we use the most. With the hybrid, we're combining the predictive with material testing. So we're actually coming in and reading what the radio frequencies or what happens to them when it passes through the walls. And so that data gives us the information we need to put into the predictive to say, this wall causes 3 dB of loss. This one over here is 8 dB of loss, and so forth. It's a reasonable balance between cost and time. You do need a good design tool like Ekahau or Hamina. It is way more accurate than just winging it, but we can make it even more accurate by adding in things like the furnishings. We often put in things like cabinets, appliances, big flat screen TVs, metal filing cabinets, any of this type of stuff that might get in the way of our signal. Now, the other thing is you have to decide whether you want to do this in-house or use a design partner. So do you have enough work to justify the cost of all the equipment? And do you have the people that can handle it? Keep in mind, this is a learning curve to get up to speed on these products. The basic level of training on Ekahau runs about $6,000 for 2 weeks. And then training to gain enough knowledge in wireless in general, a base education in wireless, is another $6,000 to $8,000 in 2 to 3 weeks of time, plus the cost of the equipment. So this can get up there pretty quick. Now, compare that to having an outside vendor do it. And this is just a ballpark, but most solid hybrid designs come in around $7,000 to $14,000 for an arena or a large event area type space. So when you look at it, do you spend $10,000 to $20,000 for a one-time thing, or do you just have a vendor do it and move on? So that's your choice, whatever makes the most sense. So some key design tips. We want to make sure we draw the walls in accurately relative to their RF loss, as well as the dimensions. We use areas within the tool to create spaces that say, I need this level of coverage here versus over here, I need a lesser coverage. So for example, in an arena, or not an arena, say an outdoor event space, you may want to have the best coverage where the vendors are all set up, but then lesser coverage out by where the people are. That's your design and your choice. Then you can do that and you can set the scale so that it helps you to guide you better. You need to factor in all the major furnishings and things like large aquariums. We've run into that before. Lockers, racks, shelving, all of these various things that I mentioned here. Plus the crowd, you can factor that in some of these design tools. So you can lay out a crowd that's seated versus standing. We want to factor in elevator shafts, the IT room, electrical panels, vehicles. If this is an outdoor space and we've got vehicles parked, we need to account for that because it's going to change the coverage. We did some designs for churches during COVID that were moving to outdoor service, but they were broadcasting it via Wi-Fi to people, and they found out that it looked great on paper until the cars showed up. And then when everybody pulled into the parking lot, their plan went to pieces because, well, the cars blocked Wi-Fi. And then you have to pick your primary use case or specialized uses so that you design accordingly, because everything requires a little bit different thought process. VoIP requires a different approach. Real-time locating services require more APs. Autonomous vehicles need very special coverage, because the last thing you want is a car going rogue on you or a robot going rogue. So all these different things factor in. And so I'm going to jump into the case reviews here real quick. I'm going to do these pretty quick because we're kind of getting up on our time here. So this is a gymnasium, pretty simple, flexible use, seats about 1,000. Original design, 5 APs, all Omnis, really didn't work well, and they were all going end of life. So when we did the new design, this was the predictive, and this predictive, by the way, did match the outcome fairly close. We were actually a little bit overboard on the actual versus our predictive. So that's better because then we can scale back the power. Our new design called for 4 directional APs mounted pretty much where you see them here on the picture. Each one of these was high capacity for 768 users. They were over top of the bleachers, face down, and about 24 feet up. And so these are giant cones of coverage on these particular. And then we also had an Omni high capacity up at the top that was for a overhang area where people came in and hung out a lot. So that was actually above, well, not actually above, but it was above the bleachers, but the Omni was a good choice there. This is a church sanctuary that we did. It seats about 4,000 people. Heavy streaming use from the attendees, believe it or not. And they also wanted solid coverage so that all 4,000 attendees could answer polling questions at the same time. This is tiered stadium seating. Ceilings were anywhere from 45 to 60 feet, and it needed to blend in. So the current solution had been end of life for about 2 years when we got into this. And so the solution was 8 high capacity APs over the sanctuary, and then another 18 or so in the hallways and areas surrounding it, which provided the transition support as people came in and went out of the sanctuary. And then this tied into the existing wireless network, which was covering a total of about 250,000 square feet. This is an example. These are mounted up in the rafters above the sanctuary. So you can see the directional antenna extended on a pole out over the crowd, properly secured. And then the AP was mounted to the structure inside. So we used the antenna lead wires to allow us that standoff there. And as you can see in the picture in the upper right corner, you can almost not even really see these from the ground. They kind of blend in pretty well. And then the one in the bottom right is just an example of one of the Meraki APs that was in the transition mode as people came in or left that area. Another one that we did was a conference center. This was a ballroom area, a lot of divider panels, really creating a lot of problems. up to 4,000 people here, and all APs had to be above the tiles because they didn't want to see them. So this is the floor plan. It's pretty large, and this guide gives you a general idea of the space. It was standard conference room space, a couple of meeting rooms, the boardroom, and things like that. Not very tall ceilings. These are about 14 feet up, give or take. So we did a hybrid design here. This called for 17 Wi-Fi 7 APs that had scanning radios built into them. These are also high capacity. And then 7 with moderate capacity for the back of house and low use areas. So just to keep that transition, our design pattern, this is it right here. You can see where they were in the main ballroom. We designed it so that the panels could go up, but then they also turn off some of the APs when the panels are down, because it's too much if the panels are down. And so they manage it and maintain it as they go. So the interesting thing about this conference center is it's part of this next one. So a little quick step back in history for those of you that have been around a while. You might remember when the U.S. men's hockey team at the 1980 Olympics defeated the Soviet Union to get them into the medal round for the gold. So this is the Miracle on Ice team, and this conference center is attached to the arena where this hockey match occurred. And this is the arena itself, and this is what we just recently did a design for. Current system was failing. It was actually designed by the vendor, and it was not designed properly. We had a total of 3 ice rinks with up to 7,500 people in the main rink, 1,000 in each of the others. And we're dealing obviously with tiered seating, metal and concrete structures, poor cell service, high interference, and the majority of the users are under 21. So heavy social media users. And this thing can be converted for many different things. So we did a hybrid with some AP on a stick mixed in, testing new access points that were not available for shipping yet. So everything we were under NDA on. We observed the actual users, seeing what their patterns were of use. We did a thorough testing of all the structural elements, and then did a solid predictive based on that. And I think the most important lesson here was don't fall on the ice when a bunch of kids are taunting you as you walk out on it. That was quite nerve-wracking when I'm walking out on the ice with kids sitting there laughing at me, hoping I would fall and they could laugh some more. So the solution, this is the main arena. We did 4 in the center off the scoreboard. These are high-capacity stadium antennas. And then the 6 under the bleachers are high-capacity APs as well, and they're back up underneath the bleachers to cover the walking areas and the areas that the stadium APs couldn't see. All of these are tri-band, except the 4 up in the top. They're only dual band 5 and 6 gig. We really don't care about 2.4 in this case, but all had scanning radios in order to keep the spectrum the best it could be. And so you can see here in the upper right-hand corner, we've got one of them mounted on the rails looking down over the arena, and walking out on the ice to test it is an important part, because they use the ice for other things such as dinners, events, and such. So they had to have full coverage even on the ice, not for the hockey players, but for everything else. And then we also did the outdoor speed skating rink as an outdoor model, up to about 1,000 people out here. And we just leveraged the light poles and directional APs out here as well, and got a thorough coverage with just 4 APs out there. So to wrap this up, keep in mind your overall open space is going to have a lot of challenges. Takes a lot of planning. You need Wi-Fi 7 features like MLO and preamble puncturing to get by in these areas. You need an experienced resource, and you might need to mix brands to get to the APs that you really need. So keep in mind, directional antennas are your best friend here, not the Omni. And so with that, Chris, go ahead with the questions.
All right, thank you very much, Alex. Information. No questions here today, so I will we'll give you back the rest of your afternoon. Thank you very much for each of you participating today, and for Alex for the information. And we hope you have a great afternoon. Thanks, everyone.
Have a great day.